Let's solve further examples on differentiation of parametric equations. Now for a given cycloid is an example of parametric equation. We're given x is 4 into theta minus sine theta and y is equal to 4 into 1 minus cos theta. And we're asked to evaluate the y dx and also the square y dx squared. Now let's recall that the y dx is given as the y d theta divided by the x d theta. Remember that theta is the parametric, the parameter. And the square y dx squared is given as d d theta of the y dx divided by the x d theta. So in this case now, let's evaluate the y d theta and likewise the x d theta. So given that y is 4 into 1 minus cos theta, so this can be simplified as 4 minus 4 cos theta. Therefore, our dy d theta is what? Minus 4 into minus sine theta. Because when we differentiate cosine, we will have minus sine. And this is equal to 4 sine theta. So having evaluated the y d theta, let us also evaluate the x d theta. We know that x is equal to 4 into theta minus sine theta. Then let's open the brackets. We have 4 theta minus 4 sine theta. So our dx d theta therefore will be 4 minus 4 cos theta. Because when we differentiate cosine, when we differentiate sine function, we have positive cosine. So this can be simplified further as 4 into 1 minus cos theta. Now, having evaluated the y d theta and the x d theta, let's then evaluate the y dx, because the y dx is the y d theta divided by the x d theta, and our dy d theta is 4 sine theta, and our dx d theta is 4 into 1 minus cos theta. Now 4 nullifies is 4, and we left with sine theta over 1 minus cos theta. Now we are done with evaluating the y dx. The next thing we are going to do is to evaluate the square y dx squared. The square y dx squared is d theta of the y dx divided by the x d theta. Now we know that the x d theta is 4 into 1 minus cos theta, and our dy dx is sine theta minus 1 minus cos theta. Now let's differentiate with respect to theta of dy dx. That's differentiating with respect to theta of sine theta divided by 1 minus cos theta. Now taking a look at this, we realize that this is differentiation of a quotient where sine theta is u and 1 minus cos theta is v. And for quotient rule, just like we have done in this series of video number 9 and 10, differentiation of a quotient, we have that the quotient rule says that the y dx is equals to v du d theta, or du dx. Let's stick to theta. So the y d theta is v du d theta minus u dv d theta divided by v squared. So let's simplify further. Our u is sine theta and our v is 1 minus cos theta. Du d theta, that's differentiating sine theta, will give us cos theta, and dv d theta will give us minus into minus sine theta, and that is sine theta. Therefore, d theta of sine theta divided by 1 minus cos theta, applying quotient rule, we have it to give us v, and our v is 1 minus cos theta multiplied by du d theta, that's cos theta, minus u, which is sine theta, multiplied by dv d theta, that is sine theta, divided by v squared, 1 minus cos theta squared. Now let's simplify further. This will give us cos theta minus cos squared theta minus sine squared theta divided by 1 minus cos theta squared. This will give us cos theta minus into cos squared theta, that's factorizing with minus 1, plus sine squared theta divided by 1 minus cos theta squared. From trig identities, we understand that cos squared theta plus sine squared theta is equal to 1. So we have cos theta minus 1 divided by 1 minus cos theta squared. This is an expression of d theta of sine theta over 1 minus cos theta. Now let's go back to us evaluating the square y, the x squared. We understand that the square y, the x squared, is d theta of the y dx, which is sine theta over 1 minus cos theta divided by the x d theta, and the numerator is given by this expression, that's cos theta minus 1 over 1 minus cos theta squared, everything divided by the x d theta, and we can see that the x d theta is 4 into 1 minus cos theta, 4 into 1 minus cos theta. Now let's simplify this expression to evaluate the square y, the x squared, and this will give us cos theta minus 1 divided by 4 into 1 minus cos theta multiplied by 1 minus cos theta squared. Therefore, the square y, the x squared, is equal to cos theta minus 1 divided by 4 into 1 minus cos theta cube. Can we simplify further, having cos theta minus 1 at the numerator and having 1 minus cos theta cube at the denominator? Yes, we can. Let's make this in terms of 1 minus cos theta. Let's make the numerator in terms of 1 minus cos theta. And that will be an introduction of factorizing by negative. So this will give us 4 into 1 minus cos theta cube. Therefore, the square y, the x squared, will be left with minus 1 over 4 into 1 minus cos theta squared. So this brings us to us evaluating the square y, the x squared. Let's take one more example. You might be asked to evaluate the equation of a tangent or a normal when it comes to parametric equation. That's question 2. Let's take now we're having to determine the equation of a tangent drawn to the parabola, given that x is 2t squared and y is equal to 4t, and the point given is t. Now let's recall the equation of a tangent that says y minus y1 is equal to m into x minus x1. Okay, we know that m is the gradient, that's the y dx. M is the gradient, that is the y dx. And in parametric equations, the y dx is given as dy, because t is our parameter, the y dt divided by the x dt. So let's evaluate that. Our y is equals to 4t, our x is equals to 2t squared. The y dt is equals to 4, and the x dt is equals to 4t. Therefore, our m, which is the y dx, is equals to the y dt divided by the x dt, and that will give us 4 divided by 4t, which is equals to 1 over t. So our m is 1 over t. Now, having evaluating our m, let us now evaluate y1 and x1. Now, y1 is the value of x of y, value of y at point t, and x1 is the value of y of x likewise at point t. Usually we are used to giving a particular value for the point or a corresponding coordinate, maybe 1, 2. Now we understand that y is equals to 4t and x is equal to 2t squared. Now y1, that means wherever we see t, we substitute t, will still remain 4t, and x1, wherever we see t, we substitute t, which will still remain 2t squared. Now let's evaluate our equation of tangents now. Recall that the equation of tangent is y minus y1 is equals to m into x minus x1. So let's substitute. This will give us y minus y1, that's 4t, is equals to m 1 over t into x minus x1, which is 2t squared. Now we can leave our answer like this. This then becomes the equation of tangent. We can also add to evaluate the equation of normal. So we call that for normal, y minus y1 is equals to minus 1 over m of x minus x1. So let's substitute. That's y minus 4t is equals to minus 1 over t of x minus 2t squared. Now this is y minus 4t of minus t into x minus 2t squared. Now this is our equation of normal.